Okay, here are your notes on section 7.3. So today we're talking about angle-angle similarity and side-angle-side similarity and side-side-side similarity. So these guys are going to be very, very similar to our theorems that we use to prove triangles were congruent to each other. So almost the same idea. Okay, so we're going to start off by just defining some stuff. Angle-angle similarity, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay, so that sort of looks like, let's say these two, and I'm telling you that these two angles are congruent and these two angles are congruent. I'm saying to you that if the two angles of one are congruent to the two angles of another, then that is enough to say that the two triangles are similar to each other. Okay? We can say that they are similar. One has been blown up or reduced compared to the other one. Side angle side, if an angle of one triangle is congruent to an angle of another triangle, and the sides including them, that means the two sides on both sides of your angles, the two sides including them are proportional. Then the two triangles are congruent. So then the two, or not congruent, sorry, similar. The two triangles are similar. Okay, so this is side angle side. So we've got two triangles, maybe one is bigger than the other. And we know that this is, let's say, 2, and this is 4, and let's say this is 3, and then this is 6. So we've doubled the side lengths, so they are proportional to each other because 2 is to 4 is equal to 3 is to 6. Okay, they both reduce to 1/2. And so since they're both 1/2, their sides are proportional. If I told you that the angles between them were also congruent to each other, then you know that those two triangles are similar by side angle side. Okay? Side, side, side. If the corresponding sides of two triangles are proportional, then the two triangles are similar. Again, side, side, side. Let's say they're giant. Okay, so let's say we made this 1, 2, 3, and we doubled it in size. So we have 2, 4, 6. Every one of these, 1 is to 2, is 1/2. 2 is to 4, reduces to 1/2. 3 is to 6, reduces to 1/2. So they're all proportional by side, side, side. Okay? All right, we're going to move this up, and then we're going to talk through some examples because this is just a matter of practicing these examples. See if I can get this just right. It's not very cooperative. Okay. There we go. All right. So looking at example number 1. Okay, so the line got erased here by accident. So looking at example number 1, we're going to make some comparisons. We're going to decide whether or not the triangles are similar, okay? So you're just going to decide that by looking at these pictures. So right now, what you do know about this is that you have vertical angles that are congruent to each other, okay? So those ones we know because they are vertical angles. So that's great. Okay? The other thing that you know, and we haven't talked about this in a very long time, is that we have two parallel lines here. And anytime you have a situation where you have two parallel lines, so two lines that are parallel, and you know they are because they put these little triangular symbols on them to tell you that they're parallel to each other. And then you take another line and you cross it. So right now I'm talking about this line and this line being parallel, and this is the line that's crossing it. What happens is you end up with what's called alternate and interior angles. This is the interior. It's between the two parallel lines, and we're going to talk about the angles that are alternate from each other. So that one and that one. Those two are what we call alternate. They're on opposite sides of this line, opposite sides, and they're inside the two parallel lines. So alternate, interior. So by knowing that they're alternate and interior, I know that since they're alternate and interior, I know that this one is congruent to this one. By the same token, I can look at these and know that they're the parallel lines and that this is the transversal. So I get these alternate and interior angles. And if I have all three angles, I don't need all three, I only need two of them. I can say that yes, these two triangles are similar by angle, angle, similarity. I just needed to prove two of them, but in fact in this case we have all three of them. Okay, let's look at the second example. So now I'm looking at them and I'm thinking, okay, I have an angle and I have sides on either side of those angles. So this is a potential side angle side. A lot of students at this point would say, oh yes, that's side angle side. We have 3 and 6 on this side, or 6 to 3, and then we have the two angles, and then we have 10 to 4, and those are on both sides, so they include the angle. And most students right now would just be like, oh, that's side angle side. But you should test it, because you have to know that the sides are proportional. In other words, 6 is to 3 has to equal 10 is to 4. They have to reduce to the same amount. So these are both divisible by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. These are both divisible by 2. 10 divided by 2 is 5, and 4 divided by 2 is 2. These are not proportional. So the triangle was not blown up or reduced by the proper proportion. So this one is just not proportional, so not similar. If I asked you why they were not similar, you would have to tell me that the sides are not proportional. Okay? Sides not proportional. Okay? All right. In example number 3, I'm going to ask you to use a strategy we used before when we were proving triangles congruent, and that is to take the two triangles apart. So we have our little triangle here, and I'm just going to redraw it up here, and it says 20 and 25, okay? And then we also have the large triangle, which is this one, and then you need to figure out how much is this total side. If this is 20 and this is 25, right? So you have to add it together. And so the bigger triangle is 45, and this side is 25 plus 30, or 55. Okay, so big angle and little angle. Remember that they are both sharing an overlapping angle. They both have an angle A. So again, this is a potential side, angle, side. Side, angle, side. The only thing we need to do is check to see that they're proportional. Okay? So 20 is to 45. We're going to check that. All right. Both divisible by 5. So 20 divided by 5 is 4, and 45 divided by 5 is 9. Okay? Let's check the second one. 25 is to 55. All right, both divisible by 5. 25 divided by 5 is 5, and 55 divided by 5 is 11. These are not equal. So this is another not similar, and it's because the sides are not proportional. Okay? Sides are not proportional. Number 4, exactly the same as number 3, in that we're going to use the same strategy. So we're going to redraw the little triangle. Okay, 3, 2. We're going to redraw the big triangle. Oh, I forgot the 3 here. Hang on. And then we're going to redraw the big triangle. This entire side, 5 plus 3, gives me 8. 2 plus 3 and a third gives me 5 and a third. And then the bottom is 8. So I have to make sure that I have some sort of a situation here, side, angle, side, 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 or angle, angle. Okay? I do know that they share this common angle, right? That's the overlap. So this could be a side, angle, side. So let's check. 3 is to 8. Okay? And then we're going to do this side. 2 is to 5 1/3. Okay? An easy way to do this is just to work it out and see if those numbers are divisible by the same. So you're going to look at them, you're going to convert them with your calculator, and you're going to check them out. And what's going to happen is you're going to try to see if they're equal. Okay? And you end up looking at the proportions here. 3 divided by 8 is 0.375, but then you have to do 2 is to 5 or 5 1/3. So you're going to have to take your calculator out and do 2 divided by 5 1/3, and you're going to get 0.377. Not exactly proportional. Okay? Again, we're going to look at number 8. Redraw the triangles. Little triangle. 8, 8. We're going to redraw the big triangle. 8 plus 10 is 18. 8 plus 10 over here is 18. We have our overlap right here. So again, potential side, angle, side. 8 is to 18. 8 is to 18. So this is a yes, and it's by side, angle, side. 8 is to 18, so proportional. Pretty easy to tell. Number 6 is a little confusing because, again, we had a flip happen here. Just going to be really careful. You could also think about it as a turn. So if we took this triangle and we turned it around, we would have this congruent to this, and we would have this congruent to this, and then we would have this matching corresponding to that. Okay, so there's our corresponding sides. Now we just need to take a few minutes and see if we have side, 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 because we know no information about any of the angles, so we're going to have to check the sides. Okay, so we have 40 is to 60, okay, which reduces to 2/3. We have 30 is to 45, okay, which reduces to 2/3. And then we have 22 is to 32, which reduces to 11 over 16. So no, because the sides are not proportional. Okay, so those are examples of being able to tell whether or not your triangles that are given to you are proportional or not. Now we're going to talk about using proportional triangles to solve for a missing piece. So let me scroll my page up for you. Okay, see if I can get this to scroll. All right, and so we are going to use this to tell excuse me, to tell whether or not, or to try to figure out that piece that we're missing. So you're just going to tell why the triangles are similar. All right, so these two triangles are similar because of angle, angle. We have two angles. So that's the reason that they're similar. And now we're going to use what we know about them to solve for x. So x is to 5. Those are the two sides that correspond to each other. They're the side that has no marking and one marking, no marking and one marking. Okay? So these two sides. X is to 5 as 4.5 is to 3. Notice I always go from this triangle on the right to that triangle on the left. I'm always keeping it consistent. So 4.5 is to 3. You have to cross multiply. 3x is equal to 22.5. You're going to divide both sides by 3, and x equals 7.5. Done. Second example, really important again that you pull them apart. Okay, it's really super important. They are telling you that this part is 110. This is really important information because you know that if these two angles form a straight line, which they do, they add together to give you 180 degrees. And if this section on this left side is 110, then this section on this side has to be 70, so that when I add them together I get 180 degrees. Why do they need to tell you that? Well, it's important because when you take this little triangle and you take it off and you put it over here, you know that this side is 3 and you know that this angle is 70, which means it has to correspond to that one in the large triangle. That's important information. Okay? So we have 3, we have the angle, and then we have this side which we have labeled as x. So that's the little triangle. Then you're going to focus on the big triangle. Okay, so here's my big triangle, which I know this is 70 degrees, so I know it corresponds. This entire side that I'm drawing my line over and over on is 3 plus 3, or 6. And then this side is 5. So now I have my ratio. I can set it up. 5 is to, or x is to 5, sorry. X is to 5 as 3 is to 6. Cross multiply, 6x equals 15. Divide both sides by 6. X equals 2.5. Done. Those two triangles are congruent by side, angle, side. Okay, so this one was angle, angle, 7.5, and then the second one is side, angle, side, 2.5. Okay, let's look at the third one. Little triangle, we've got these guys, yes, vertical angles. So I've got angle, angle, similarity, which is fabulous. And then I just need to set up my proportion to solve it. So x in this triangle is 2. It's the side that has nothing and 2, and this is the side that has nothing and 2. So x is to 22 as 14 is to 24. 24x is equal to 308. Divide both sides by 24, and x equals 12.8. Okay. This particular triangle is, again, an overlap, right? So we have two parallel lines cut by a transversal. So if we think about that, we have two parallel lines, and they're being cut by a transversal. So that means these two angles are what we call corresponding. They have to be the same. If I took the top triangle and just kept sliding it down and sliding it down and sliding it down until it sat exactly over this one, those two angles would be exactly the same. These two angles would be exactly the same, and they already share the vertex angle. So it's really, really easy for us to see these two triangles are similar by angle-angle similarity. And then we have to write our proportion. Again, with these overlapping triangles, before you write your proportion, you really should take them apart. 6, 9 for the little one. Just remember that when you redraw the big one, you have to remember to add the stuff together that forms that large side. So 2 plus 6 is 8. So now my proportion is going to say x is to 9 as 8 is to 6. And we're going to cross multiply. 6x equals 72. And divide by 6. And so x equals 12. Okay? Same exact problem for number 5. Again, the same deal with the parallel lines. So we get these angles congruent and we get these angles congruent. And we already know they share the same vertex angle. So angle-angle similarity. And then we, again, pull the two triangles apart. 4, 5. And then the big triangle is going to be 4 plus x. That's what this whole side would equal. I'd have to add them together to figure out what the total is. And since I don't know what x is yet, I'm just going to have to say, well, that entire length would be 4 plus whatever x is. So 4 plus x. And then the bottom here is 15. So we have to set up a proportion. This one's going to be a little bit tricky because we're going to have to use some algebra to do this. 4 is to 4 plus x as, so I'm going this way, 5 is to 15. And I have to cross multiply. Okay? So I'm going to do this first. 5 times 4 plus x equals 4 times 15, which is 60. Distribute the 5. 5 times 4 is 20. 5 times x is 5x equals 60. I'm going to make a little bit of room here for us to finish this problem. Okay. So I have to move the 20 to the other side of the equation. 5x equals 40, and then I'm going to divide both sides by 5, and x is going to equal 8. Nicely done. Number 6, same deal. We have the same situation with the angles being congruent because of those parallel lines, and then of course they share their vertex angle. So I have angle, angle, similarity, and then I have my two triangles. I've got this guy that has x over here, and it has 12 on the bottom. And then I've got the bigger triangle, which is x plus 7.5, and then the bottom is 18. So this one's a little tricky. We have a couple of variables in a couple different places. We have x is to x plus 7.5 as 12 is to 18. Okay? Cross multiply. 18x is equal to 12 times x plus 7.5. We're going to need to distribute. 18x equals 12x plus 90. And then I'm going to subtract the 12x so that I can collect all of my x terms on one side of the equation. 6x equals 90. Divide both sides by 6, and x equals 15. Okay? Very nicely done. So the first 6 we did was just telling whether or not they were similar to each other and which property we used to do that. The second 6 was about solving them if we knew that they were similar. And the last 2 are word problems where you're just going to apply what you know about similar triangles to solve a couple word problems. So I will say to you visual learners that pictures are going to be your friends for these. So in the sunlight, a cactus. So here's my cactus. Okay, just pretend. It's pointy and it will hurt you. Don't touch it. Your cactus casts a 9-foot shadow. So here's my shadow from my cactus. At the same time, a person 6 feet tall, so this is 6 feet, casts a 4-foot shadow. Use similar triangles to find the height of the cactus. So we want to know what's the height of the cactus. So remember, we're going to make the assumption that the cactus is growing at a 90-degree angle with the ground, nice and perfectly straight. And we're going to also make the assumption that this human being is standing with perfect posture, creating for us these two right triangles that we are told are similar. Okay? And so the sun is shining at the same angle for both of them, so they have the same, they're similar. They have the same sort of setup. X is to 6 as 9 is to 4. Cross multiply, 4x equals 54. Divide both sides by 4, and we find out that the cactus is 13.5 feet tall. That is one big cactus. They must be out in Arizona somewhere in the desert. 13.5 feet tall is the height of the cactus. Okay. Jamie places a mirror 24 feet from the base of a tree. Here's my tree. Okay, 24 feet to a mirror. Okay, so I'm just going to put M here for mirror. Okay, 24 feet to the mirror. She stands 3 feet from the mirror. She can see the top of the tree reflected in it. So she's standing here. Okay. This girl, oh, that's not a very good girl, is it? I'm drawing like weird shaped heads here. Let's see if we can fix this. All right, so we have this girl. Here's her skirt. This girl is 3 feet from the mirror. So there's 3 feet in there. And it says that she can see, so she's looking into the mirror, and she can see the top of the tree. So they're trying to tell you that we're forming a triangle here. Her eyes are 5 feet above the ground, so she's 5 feet tall. And it's saying how tall is the tree. So what they're asking you to do is to recognize that there are two triangles here. This one, 5 feet tall, and 3 feet away from the mirror. And then there's this one. How tall is my tree with a 24-foot shadow across the bottom? Okay, how tall is the tree? Well, let's figure it out. X is to 5 as 24 is to 3. We're going in this direction. X is to 5, 24 is to 3. Cross multiply. 3x equals 120. Divide both sides by 3, and we find out that the tree is 40 feet tall. Okay? All right. Really nicely done.